Yeah, hi guys. Today our topic is most important topic in the 100 topics. Today is the most important topics from the respiration. There is a transport of gases which is oxygen and carbon dioxide. If they come to the oxygen, today we are going to discuss the transport of oxygen, how it is bind with the hemoglobin. What is the graph shows the binding between the relation between the hemoglobin and oxygen. Okay, yeah, how it is dissociated in the tissue, associated in the lungs. We are going to discuss the things which is going on in this session. Okay, most important, my dear doctors. Okay, we are going to discuss today topic. Okay, yes. Okay, yeah. Transport of gases, oxygen and carbon dioxide takes place via blood. Okay, blood is the medium which is transport the gases. Okay, yes, and mainly oxygen and carbon dioxide we are going to discuss in this session. Oxygen, okay, oxygen, the blood carries oxygen from the lungs to the heart, from the heart to the blood body parts. Okay, yes, and yeah, transport of oxygen as oxyhemoglobin. Okay, what is oxyhemoglobin? Okay, yeah. Okay, oxyhemoglobin. Hemoglobin is a red color, like it is red color pigment, iron containing pigment present in the RBC, and oxygen can bind with the hemoglobin reversible manner, and each hemoglobin molecule can carry the maximum amount of 4 oxygens, and binding of oxygen with hemoglobin is primarily related to the partial pressure. Okay, every 100 ml of blood which is carry the 5 ml, which is delivered 5 ml of like oxygen in the tissue. Guys, we will going to discuss what are the how many you people attend short rate. Okay, yes, okay, yes. Today we are going to discuss oxyhemoglobin dissociation curve, and the factors affect the oxyhemoglobin binding, and the favorable conditions are there for this curve. Okay, we are going to discuss today's session, guys. Yeah, transport of oxygen. Oxygen via blood, okay, from who can transport? Blood can be transport. Okay, yes, and first oxygen where it is reach? Lungs. Lungs can reach oxygen from the lungs, which is the blood vessel which is enter into the lungs. Oxygen which is enter into the lungs, oxygen reach blood vessel. Okay, there is a relation between lungs and blood vessel. Okay, the blood which is oxygen enters into blood, the process diffusion, the process called diffusion from the blood oxygen can reach tissue, the process called diffusion. Tissue utilize oxygen give energy ATP plus CO₂ plus temperature. This is the mechanism where oxygen start, where oxygen end. Okay. Yeah. Guys, so where the oxygen transport from where it is produced in the atmosphere with the partial pressure 159 mmHg, if it is come to the like lungs, it is 104 mmHg. If come to the oxygenated blood, which is 95 mmHg. If come to the tissue, finally it is 40 mmHg. So oxygen can transport, which is from the atmosphere to tissue. It is delivered in the tissue utilize and release the CO₂ here in the tissue. The CO₂ at the same time, this can be transported through the direct mechanism into the lungs, and finally it can be delivered into the atmosphere. Same manner, the who can carry the oxygen here or carbon dioxide, there is a pigment called hemoglobin. Okay. We are going to discuss how the oxygen bind with the hemoglobin, how carbon dioxide bind with the hemoglobin. Okay. Yes, this is the main important topic, guys. Okay. You have to be like listen carefully. There may be a question in this topic. Transport of gases is the most important in the respiration. Okay. You guys stay tuned. Okay. I will give you full explanation about it. Yeah. Okay, guys, transport of oxygen. Transport of oxygen from where? From lungs to blood, blood to tissue. It is transported from lungs to blood, blood to tissue. Finally, the oxygen will reach tissue. Oxygen will reach tissue. Okay. Tissue utilize oxygen and release energy. As you know, who can carry the blood? In the blood, what is the pigment carry the oxygen? We are going to discuss, okay, with curve. This is lungs. The oxygen which is enter into the lungs in the lungs there is a alveolar sac. Okay, in the lungs I have to take the alveolus in the lungs. Oxygen will reach alveolus in the lungs. The sacs of the lungs is alveolus. Alveolus. The blood can reach around the alveolus. This is the blood vessel. There is a oxygen which is transport from the alveolus to the blood vessel. The process called diffusion. Diffusion. So, who can bind the oxygen? Bind with whom? Bind with whom? In blood vessel. Okay, that is called, there is a pigment called hemoglobin. There is a pigment called hemoglobin. Okay. This hemoglobin is what? First we have to know what is hemoglobin. Okay, where it is located in the RPC. This is the blood vessel. I am going to drag here. This is the blood vessel. This is the blood vessel. Blood vessel, there is a pigment called hemoglobin. This is RBC. RBC. I will give you clear. Blood vessel, In the blood vessel there is a RBC, biconcave shape. This is RBC. This is plasma. Blood nothing but there is RBC and plasma. Plasma it is about 55%, RBC about 45%. Oxygen carry forward through the two mediums, blood cells. This are not a RBC, blood cells. Blood cells 45%, blood cells, RBC and plasma. Through these three medium the oxygen will carry. Through the plasma they can carry in the dissolved form. Dissolved form. Dissolved form oxygen can carry. If it is 100% oxygen, just 3% they can in the dissolved form. Oxygen unlikely to dissolve in the solutions. In that way oxygen can dissolve in the plasma 3% only, that can be delivered in the tissue. This is the tissue. This 3% oxygen directly deliver in the tissue, 3%. Okay, 97% through the RBC. 97% through the RBC. The RBC, how it is carried? There is a pigment called hemoglobin. Hemoglobin. Heme plus globin chain called hemoglobin. This is hemoglobin. Two alpha chains, two beta chains, hemoglobin. Hemoglobin has its own head part and tail part. Head part heme and tail part globin. Head part heme and tail part is the globin. Who can carry oxygen, head part or tail part? Okay. Heme mean iron content. Heme mean iron content. The oxygen can carry through the head part, where oxygen enter, thus can be attached into the head part primarily. Each chain they can bound with the one oxygen. 4 chains they can carry 4 oxygen molecules, mean alpha chain 2, beta chain 2. 4 chains hai na, 4 chains they can carry 4 oxygen molecules. The hemoglobin maximum carries 4 oxygen molecules. Four oxygen molecules. through their head part of the hemoglobin. That is head part which is iron contain, iron plus O2 oxidized state, they can bonding. The partial pressure here in the oxyhemoglobin (95 mmHg). In the oxyhemoglobin, 100% 100 ml of blood carry 20 ml of oxygen. How much they deliver in the tissue? This is the question. How much deliver in the question? This deliver in the tissue? This is the question. Okay. So, maximum amount of hemoglobins, each hemoglobin carry maximum amount of 4 oxygen molecules. They deliver one here, one here, one here, one here. They can carry 4 molecules but deliver only one. Okay. They can carry 4 molecules but deliver only one. Deliver only one. Only one mean if it is 420, if it is 4 molecule oxygen molecule 20 ml. If it is 1 out of 4, 1 deliver mean 5 ml deliver. Okay, 5 ml it is deliver. How much? Deliver in the tissue 5 ml. Mean 1 molecule only deliver in the tissue. 1 molecule oxygen. Each hemoglobin carry maximum 4 but 1 deliver in the tissue, not 4 amount of oxygen. Each hemoglobin they do not like deliver 4 oxygen molecule in the tissue. Remaining 3 molecules Hb plus O2, which is 3 molecules of O2, they enter into the deoxygenated blood. Deoxygenated blood mean deoxygenated blood also has 75% of oxygen. Deoxygenated blood also has 75% of oxygen. So, this is the way oxygen how they can carry forward through the hemoglobin. there is a main reason which is oxygen to bind with the hemoglobin is the partial pressure. Partial pressure in the oxygenated blood, which is like 95 mmHg, right? 95 mmHg. In the lungs, which is 104 mmHg. So, how it is bind? When partial pressure of oxygen increases in the lungs, the affinity of hemoglobin for oxygen is increases. This is the scenario we can call Haldane effect. Haldane effect. This is theory we can call Haldane effect. I hope you guys understand this. Guys, just listen carefully. Transport of oxygen. First, oxygen can reach lungs. In the lungs, they can fill in the alveolus. The blood vessel which is associated with the alveolus, they can capture the oxygen via diffusion. There are 3 layers involved in the diffusion in the epithelial cells. Okay? Yeah. Apart from that, if they enter into the blood, in the blood there is a pigment called hemoglobin that can be catch the oxygen, that is binding with the head part of the hemoglobin. Hemoglobin has 2 parts, head parts and tail part. Head part is the heme part, heme mean iron, tail part is the globin, globin is amino acid. So, oxygen always bind with the head part. 4 chains of hemoglobin carry 4 oxygen molecules, mean each chain carry 1 oxygen molecule. They can bind with the head part and they can carry into the each part of the body in the body tissue. Every tissue they can reach oxygen via hemoglobin. So, the head part of the hemoglobin 4 oxygen molecule, 1 oxygen molecule itself deliver in the tissue. Remaining 3 chains, 3 hemoglobin chains, they can attach itself oxygen carry through the deoxygenated blood, where the tissue produce carbon dioxide to attach binding with the tail part of the hemoglobin, that is the tail part, 1 chain catch the carbon dioxide, remaining 3 chains has its own oxygen molecules. Because of without oxygen there is no tissue, there is no tissue going to alive mean dead, going to become dead cells. So, in that way deoxygenated blood also have 75% of oxygen. 100 ml of blood carry 20 ml of oxygen, deliver 5 ml of oxygen in the tissue. This is the scenario. Okay? I hope you guys understand. Okay? You have to take this screenshot and I will give you the oxygen dissociation curve today. Okay? Yes. I hope you guys understand. Take a screenshot this. Yeah, next. Transport of oxygen, mainly hemoglobin is a red color iron containing pigment. O₂ can bind with the hemoglobin, it is a reversible man. So, oxyhemoglobin molecule can carry maximum amount of 4 oxygen to binding oxygen with the hemoglobin is primarily related on the partial pressure. Every 100 ml of oxygen blood can deliver 5 ml of O2 in the tissue in the normal conditions. Okay? Yes. Next, oxygen hemoglobin dissociation curve. Oxygen hemoglobin dissociation curve. Okay? Yeah, it is depend on partial pressure and the saturation of hemoglobin. Okay, oxygen saturated mean binds with the hemoglobin how much. Okay, 30 which is saturated 50, partial pressure is 30, if 30 that can be saturated 50. This is the question they did ask previous year exam. 30 partial pressure they can saturated 50% of hemoglobin. Okay, 60 it can be like 80 and 90 it can be 100. Okay, okay, I will going to explain it. Like that, 1 minute. This is this curve which is partial pressure of oxygen, partial pressure of oxygen. They can bind with the hemoglobin, that is saturation with the hemoglobin. Saturation with hemoglobin in the percentage. Okay, that is 10%, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, how much it is saturate? Okay, what is this? This is binding. Saturation means hemoglobin binding with oxygen. This is the partial pressure. Okay, just cool. I am going to explain it. What is graph? Okay, oxygen binds with hemoglobin based on partial pressure. Okay, when partial pressure increase, in the lungs, binds with hemoglobin. Okay, so hemoglobin has 4 chains, right? This is alpha chain, this is beta chain, head part and tail part. In the lungs, how much partial pressure? 104 mmHg. In the lungs, there is a partial pressure is 104 mmHg. Oxygen partial pressure 104 mmHg. Okay, in that 104 mmHg partial pressure create one oxygen to attach to one bind. Mean how much it is saturated? if one oxygen binds with hemoglobin, if it is this 4 is 100%, 4 oxygen molecules are 100% saturation. If the 4 attach here, 100% saturation. Okay. If it is one oxygen attached to the one part, which is like 25% saturate, 25% saturate, irrespective of partial pressure. If the partial pressure is high in the lungs, first one attach in the hemoglobin head part, which is 25% saturate. If it is another one attach, next another one attach oxygen, which is another 25% saturate, mean 50% saturate, 50% saturate. Okay. If come to the another oxygen add into the another oxygen add into the head part, which is another 25% saturate, another 25% saturate, which is about 75% saturated. First which is like 25% saturate, first oxygen which is 25% saturate if the binding with first oxygen. Second oxygen which is bind, second oxygen which is bind 50%, second oxygen binds which is 50%, and third oxygen if the bind, third oxygen which is bind 70%, 75%, third oxygen which is bind 70%, fourth oxygen which is bind 100% saturate, fourth oxygen, which is the partial pressure 95% is enough for the 100% saturate, 30% which is 50% saturate, 30% mean 50% mean two binding oxygens are in the 30% partial pressure. 30 partial pressure created 2 oxygen molecule to bind hemoglobin, that is 50% saturate. So 50% partial pressure, that will create 70%, 75% mean 3 molecules they can attach to the hemoglobin. 90% partial pressure create, 90 to 100% partial pressure create the another oxygen molecule which is 100% saturate here. Got it? I hope you are clear to this. You guys understand clear what is oxygen dissociation curve, which is sigmoid curve. Association curve, okay, sigmoid. Guys, just listen carefully. This is at lungs, this is natural. If the lungs partial pressure created, if the more partial pressure created, the left shift in the lungs, mean more partial pressure created more oxygen to attach, mean if it is 60 left it is, if it is 30 partial pressure, if it is 50 the partial pressure increase, if it is 60, okay, towards left in the lungs, towards left curve in the lungs. if the deliver in the tissue, if the deliver in the tissue, if it is one oxygen deliver in the tissue, that leads to the curve which is right shift in the deliver in the tissue, that leads to the rightward graph tissue mean there is a saturation will decrease in the tissue, saturation decrease in the tissue. Mean the loss of oxygen delivered in the tissue. The curve shift rightward in the tissue. The curve leftward in the lungs. This is oxygen dissociation curve. I hope you guys understand. The graph will not straight at all. The graph not straight because oxygen deliver in tissue. Oxygen delivered in the tissue. I hope you guys understand. Okay? Yeah, I have to read this. Guys. Yeah. Hemoglobin is a red color iron containing pigment present in the RBCs. O₂ can bind with the hemoglobin in reversible manner to form oxyhemoglobin. Each hemoglobin molecule can carry maximum amount of 4 oxygen molecule. Binding oxygen with hemoglobin is primarily related to the partial pressure. Partial pressure of CO₂ is and hydrogen ion concentration, temperature or other factors which can be interfere with the binding, and sigmoid curve is obtained when percentage of saturation with hemoglobin oxygen which is plotted against oxygen. The curve is called oxygen dissociation curve, which is highly useful for studying effect of factors like like CO₂ and H2 concentration, H plus concentration on binding of O₂ with hemoglobin in the alveolus, where the high oxygen and low carbon dioxide, lesser hydrogen concentration and lesser temperature are factors favorable for the formation of oxyhemoglobin, whereas the tissue is low partial pressure of oxygen, high partial pressure of carbon dioxide, high temperature, high hydrogen concentration, mean there is a low pH value created the loss of oxygen and binding with the carbon dioxide. Guys, I am going to explain how the factors affect the oxygen dissociation curve. Factors affect the oxygen dissociation curve. in the next session. That is most important. What are the factors? pH and carbon dioxide and temperature and acidity. Like pH is acidity, hydrogen ion concentration. We will going to discuss in the next class about the factors affecting oxygen dissociation curve. Okay. Today's session is over, which is the transport of oxygen, where it can be transported and delivered. What is the graph shows about it? Okay, it is the sigmoid curve based on partial pressure to binding oxygen with hemoglobin and delivered in the tissue in the like hemoglobin, that is release oxygen in the tissue. Okay, guys, factors affecting oxygen dissociation curve in the next session, don't miss it. I will give you 100% like classes for the zoology about it is 180 target 180. Okay, keep continue and give me any message or comment. Okay, like this video and share it for your friends. Okay, thank you, thank you guys.